Well, good morning. We're nearly on time. We're going to do our best to get back and stay on time. I thought the keynotes did a great job of both framing the problem and showing some of the progress. Working for NYSERDA, the Energy Authority, I was very impressed with the graph showing how utility was coming down rapidly, because in transportation we got probably two main philosophies. One's to manage the demand, reduce the trips, and the other is to move them to electricity. And if you don't have clean electricity, that's not going to work. So if you can drive a hybrid Prius in a state that's using predominantly coal, you might as well drive a regular gasoline car. So, New York State's really leading the charge. We spend hundreds of millions of dollars a year to clean up our electricity, and you can see the results in those graphs. Okay, I'm going to introduce the panel. The bios are in the program, and in the sake of time, and because they printed them in a 6 font, I'm just going to introduce them. We have Dr. Stanley Young, who's a senior researcher with NREL. Dr. Vasilis Papagiannis, I practiced that one, who's a principal at Metro Priya, and they're going to speak on Transnet, the traveler response architecture using novel signaling for network efficiency. We have Jamie Edis, who's here from DASH, a founder from DASH and an adjunct professor at NYU, and of course Alan Kornhauser, who's a professor at Princeton University. So we're going to start with Stan, and I think both he and his colleague will take questions if time permits. We're going to try to keep on track, and we'll have some questions at the end.
Okay, thank you. Thank you for giving a definition of that acronym Transnet, definitely developed by a committee, I'm sure. I'm going to present a few slides, give you an overview of this Transnet project. We flipped a coin between Vasilis and I, and since they couldn't pronounce his name, I got to give the presentation this morning. You may have heard the Transnet term in some popular press. It's actually an ARPA-E, the equivalent of DARPA, but except for the Department of Energy, an ARPA-E initiative. Where they went out for proposals and had awards. There's actually 5 teams that were awarded. That includes Georgia Tech, MIT, Palo Alto, University of Maryland, and the NREL team, the National Renewable Energy Lab team. And we are one of those 5 teams, and we're going to give you a brief overview on the concepts and what's unique to our approach. If you were to look at the other Transnet approaches, they'd have very similar themes, but a little bit different twists on how they're going about them. First, a little bit about NREL's approach and why we're even in this. First of all, is anyone familiar with the name Harry Seldon? Okay, he's one of Isaac Asimov's characters on the Foundation series, so you might get, if you ever read that, you'll see the parallels to this immediately. Human behavior. NREL has been around for 30, 40 years, and they've approached energy efficiency mainly from 2 different directions in the surface transportation fleet. We've been trying to drive more efficient vehicles, better drivetrains, different electrical drivetrains, things like that. That's on the y-axis there. And they've also been very active in fuels, low-carbon fuels, fuel mixtures, various things like that, all trying to drive to this gray line here, which is where we want to be in 2050 as far as our pathways to get the CO2 targets for our surface fleet. And this concept of Transnet, behavioral-based, is a third dimension that, to be honest, the lab is not as familiar with working with. But they quickly realized in the last 5 years, with the pressures that are on the transportation system from increased connectivity, from increased automation, and all the aspects that are, the coming revolution in transportation, that the behavioral change and the way people choose to make trips is going to have a very significant impact on the future, both for energy intensity as well as greenhouse gases. This is our Connected Traveler team. The Connected Traveler is for the NREL's moniker for this ARPA-E Transnet project. Definitely the market opportunity there, I don't have to share that with anyone in the room that's familiar with transportation. Massive amounts of waste in terms of time, fuel, as well as money related to congestion in our urban areas. The project is really centered about providing and incentivizing users, the smartphone being the platform to interface with them, of the mobility choices that they have, and incentivize them outside the realm of eco-mobility, but marry it to eco-mobility so they see the impact that they have. We have a strong team. Metropia, Vasilis is here. He's going to be available for questions, but several other universities are participating. If you take a look at the Connected Traveler program, there's various aspects of it, and we don't have time to go into them today, but one that you'll hear frequently is what we call the control architecture. How do we incorporate the concepts of adaptive learning, refined incentives, and control strategies to provide a high certainty of adoption? Now, this really smacks of Harry Seldonism from Isaac Asimov in the Foundation series, where you can't predict the behavior of one person, but as a whole, we might be able to predict aggregate behavior and influence it. So this is the aspect, getting into the idea of how do we use these tools in an aggregate manner to influence better behavior. When we're talking about control strategies, we're talking about things you may already be familiar with and some new things. Influence the change in departure time. Influence your mode choice in urban areas where we have multiple modes that are available. Carpooling, alternative routing, alternate destinations, and even the elimination of the need for some of the trips. So these are some of the control strategies that when we interface with a customer, with a client, with a user of the application saying, you're used to Google Maps or some other brand saying, here's 2 different routes, but here's a much broader range of your choices, the impacts that they have as far as sustainability, and by the way, here's the one we would like you to take as being the most sustainable, and here's some incentives to get there. On the incentive spectrum, there's the inherent stuff. We'll give you a good navigation system, and we're going to try to minimize your travel time. And predictive analytics, you know, we see something up ahead, we're trying to get you around it. But the incentive points is really getting back to human nature, you know, what's in your wallet. You get points with all your major credit cards. Now you're going to start getting points for which navigation, I call it a navigation app, but it's much bigger than that, which app you use to manage how you get around the urban area. And that's points, points, points. And you can turn these points in for products. My favorite is a Starbucks coupon. You can do it for services, transit passes, discounts, entry into some of concert, things like that. And you can even do charity. One of the favorite ones is to plant a tree. And there's a whole spectrum in this. So combined with the control strategies and the incentive strategies, that is our control architecture, a major prominent feature of this whole thing. And this is the way I put it. Within every traveler's way they get about the city, I call it an influence zone. In my personal commute, I have about 3 different options of routes I could take. I probably have a space of time of about 90 minutes. If I schedule it appropriately, I could leave early or leave late, depending on what my schedule. It's within that influence zone that we have the opportunity to nudge towards more sustainable behavior. In the lack of any information, I'm going to just minimize my disutility function, and I'll probably be towards the non-sustainable side. But if we understand that person's influence zone and we understand their how to incentivize them, or myself, you know, it might say, hey, you know, if you take route B and leave 15 minutes before you normally do, it's better for the environment, and by the way, here's a 15% discount on the Starbucks on the route. Kind of a concept in a nutshell. I'm going to transition a little bit because one of the major players on our team is Metropia. Metropia kind of is the leader in the thought concept and implementation. While RPE was putting this together, Metropia actually got some seed funds and got out there and is almost one of the first to markets with these concepts. And if you look, they're not a straight app play the way we think of it. They build the app, they go into the community, they engage business partners, they engage the local community, the Better Business Bureau, they go to the MPOs and says, here, our goal is through this app to improve the, eco-mobility, improve the sustainability, reduce the congestion in your area. So they get the partners on board in the local community to understand the whole thing. So when you look at the application interface, at first you might see something that resembles a Google Maps interface, but the more you dig into it, the more you see it's really tied to the community and tied to available services. I'm getting into some of Vasilis' slides here, so if I do a poor job explaining some of these, please ask him or have questions. But these features mirror the architecture we talked earlier. You have options presented to the end user, and I'm going to skip ahead on this for time. And this kind of gets in, the map interface on the left is what you typically enter in, origin destinations, what are my options. A feature that's really, that we're trying to augment and do in this is to validate the feature. To interface with this app, I was introduced to it about 12 months ago on this project. I went down to Tucson to try out the app and meet with Metropia. And I must admit, I went down there very skeptical. How are you going to get me to use something other than Google Maps or something else? I learned two very valuable things. One is do not visit Tucson in July. The other one is, surprisingly, it is addictive. The feedback mechanisms within like 2 or 3 car trips, I was hooked. And the power of this interactive human personal incentivation program is what we're trying to tap into. NREL's tapping in to try to validate it. NREL has the facility to take very refined vehicle traces and do calculations with respect to energy and GHG, and that's where the interface is on that project that we're working with Metropia. Again, the gamification features, you earn points and you can turn them in for various things as we discussed earlier, music, gift cards, and such. And there's another part of this gamification feature. If you're a game player, you like to see how many levels you've won, how much, you know, your character up 52 points or something like this. And built into this app to provide the feedback is all the eco measures that the user can access if they so desired. And it keeps up to date and it informs. This one I told facilities over lunch, you're going to have to explain it to me because I've yet to capture all that one. Last one, this is one we're excited about, driving up occupancy. A lot of these apps have a lot to do with a network model of minimizing time, things like this. One of the newest features of the Metropia app that just debuted earlier this year in some of the Tucson events was a carpooling function, and they call it Duo for driving up occupancy. It's specifically designed, or at least debuted, for massive events where you're limited parking and you want to make the most convenient method, eco-friendly method for people to access it, and it matches up in ride shares and gives people points. And I also show the wheel there. They're also building in a little bit of gambling, so if you like to spin the wheel, if you follow their directions, you might get, plus up 3x or something like that on your points you can trade in later. Back on the project side, this is going to be approximately a 30-month, 3-year project, working with Metropia and the other teams to try to assess driver the data sets coming from the Metropia platform, to put a better validation on the energy aspects of it, and then to explore in more detail, more theoretical basis, the behavioral aspects built into incentivizing the users. And that's all I had. Thank you.
Thank you very much. We do have time for a few questions. Yes, no? I have a question. I'd like to know who I can see where Starbucks would donate the 15%, but who pays for planting a tree, for example?
Well, we have a partnership with a non-profit organization. We have a partnership with a non-profit organization, American Forest, that are working with them, and they're planting the trees for us.
Very
nice. I'm not sure if I missed this part, but when will the app be available, or is it available already?
Well, we are in different phases. In Tucson and Austin, we're full deployed. In El Paso, we're in beta phase. In New York, we're part of the DriveSmart program with New York City DOT, and I would call it somewhere between alpha and beta phase. And we're expanding also our presence in New York. And it covers more than New York area. It's New York, New Jersey, and upstate New York also. So you can test it even here now.
Robert.
The cost. What's the cost of this pilot investigation?
I don't want to.
$2 million?
Can you shut it up?
Oh, you mean for the Transnet program? Between, I will say, 1.5 and 5 million, depending on the scope of services. No, actually 1.5 to 3, probably, depending on the scope of services. Yeah.
Okay, halfway up? Yes.
An example of behavioral change for transportation mode, would that be considered the input of the time arrival behavior changes with that instrument up there, in terms of what train to take, what mode to take.
And when it's missing, your behavior changes. So is that an example of using behavioral modification, using information?
I'll let Vasilis address in New York. I know a lot of these concepts are cast in cities somewhat like Austin, Denver, where the light rail systems that have been implemented, many people are unaware of the routes or unaware of the bus systems. So as the app learns your commute pattern, so for instance, and its attempt to influence you is pretty much saying, you know, are you aware that there is a transit alternative? There's a massive traffic jam today. The transit alternative would be this, and this is how you access it. And then incentivizing it to try it for the first time. That's a primary component in the thought process, I know, in a lot of the Midwestern cities.
We're going to have to hold it there. I apologize. If there's room at the end of the session, we'll pick up more questions. We'd like to introduce Jamie now from Dash, who's going to give us a little overview of their software hardware product.
Great, thank you. Good morning, everyone. Thank you for having us here today. My name is Jamin Edis. I am a professor at NYU, where I teach at the Stern Business School, and I'm also the co-founder and CEO of Dash. So Dash is a connected car platform. We started the company in 2012 with a vision of building a technology solution that would make any car a smart car. So although this is an academic audience and I'm part of the faculty at NYU, Dash is a commercial enterprise. We are a venture capital-based technology company based here in New York. We believe that we can do good and also make money. And so we're going to talk about some of our products, suite, our smart mobility products in market today, who we're working with, who we're partnering with. We've got the pleasure of partnering with several people in the room here today. Now, one way to bring that to life is to show you this short video. So this is a 2-minute video, if you'll indulge me as we play this. It was underwritten by Microsoft and WeWork. WeWork is a startup incubator space, essentially, where a lot of New York companies are based under one roof. So they underwrote this video, so there's a little bit of go buy Microsoft products and check out WeWork, but it brings to life what we do at Dash. So if we can just play that for a couple of minutes, please. We look at cars as a 4-ton mobile device. We thought about the cars that we were driving, seeing them really as computers with... Excuse me, let's pause that, and can we bring that up on the screen? Is that possible? Can you help me out?
Yeah, just check.
We look at cars as a 4-ton... Can you bring that up? Yeah, that's great, thanks. Mobile device. We thought about the cars that we were driving, seeing them really as computers with this big exhaust of data flowing out of them that most drivers didn't know they could access. We connect your vehicle to your phone with a little device called an onboard diagnostic reader.
From there, we gather all the sensor readings from the car, give you analytics on fuel efficiency, improving safety, telling you what's wrong with your car.
Yeah, you get it there?
Oh, it is. Yes, we did. The entire vision for Dash is built on data. If you look at the tools that Microsoft Office has, it's really changing the way that people connect every day with the collaboration tools, with the productivity tools. What Excel does is it allows us to do very, very complex forms of analysis on that data.
It's pretty cool. The visualizations bring in 3, 4, 5 dimensions to that data and really allow you to see patterns and insights that you wouldn't have been able to see.
We're working with the New York Department of Transportation. Every day, there are about 1 million cars that commute into the city.
And if you know their origin point, maybe you can develop better routes and better systems to get them to this point without congestion.
It's a very ambitious idea, and you have to convince people that it's an idea with merit that can actually benefit society more broadly. So we have to constantly stay in touch with our investors who might be in Asia, for example. And so we use Skype to make sure that we are communicating and collaborating with that community of stakeholders.
Visualizations are awesome.
At the beginning, it was really the classic tale of two guys in a garage trying to start a business.
We started looking around at shared working space, and WeWork really spoke to us. What we really fell in love with was all the other companies and the kind of dynamic atmosphere, and just feel this liveliness.
I think one of the things with WeWork and Microsoft's Office is how both the environment and the tools that we have allow us to collaborate more efficiently. Entrepreneurship sometimes can be like driving down a dark road at night without a map, not really knowing how you're going to get to your destination. It really is uncharted. I think that process is very exciting. Okay, so why did I play that video? What does it establish? We're a New York-based technology startup. We have a hardware and software product. We are certainly very mission-driven in what we do. We believe that what we built can make, sorry, can I bring back what you had there? Can make driving smarter and then in turn safer, greener, and more affordable for people, helping them save money on gas, repairs, maintenance, and insurance. We're very lucky to be able to work with companies like Microsoft and Google and several other partners to bring that technology to life. But the thing is, and that was one of the takeaways at the end, if you could bring that up on screen, is that what gets us out of bed in the morning and why we started this company at the beginning was we believe fundamentally that if you can harness the data around driving and transportation, whether that is a passenger vehicle, a commuter, a road tripper, a freight delivery logistics business, that you can help enhance the
I'm just wondering, I'm sorry.
Okay. Thank you. Sorry about that, guys. I'm just gonna keep talking.
There it is.
So, okay. So, is that if we can harness that data and build what we call the automotive graph, then that can help improve a lot of operational efficiencies involved in transportation, whether that is increasing fuel efficiency or, again, helping create cost savings for gas repairs, maintenance, and insurance, whether you're a delivery business, again, or whether you're an individual commuter. So here's an example of some of that data. So 2 years ago, we launched in January 2014 our consumer product on Android, followed by iOS. We always were excited about getting to a vision where you have this type of data. As you can see on the top left, that is the clock. This is a day in the life of New York. These are all Dash drivers. You can see it flaring up during the rush hour in the morning and in the afternoon. This is only one way of cutting that data. This is just a heat map of where our drivers are, but we can cut it by the demographics of the driver, what type of vehicle they are driving, how it's being maintained, what are their behaviors behind the wheel, what is their point of origin, what is their point of termination, are they driving in a fuel-efficient fashion. It's an incredibly rich set of data, and that is really what gets me excited every day when we do this. So hopefully this will be straightforward to bring up. So we position ourselves as being a data-driven company. And yeah, is it up there? Okay, great. So let me talk a little bit more about what the architecture of our solution is. So we're a hardware and software product. At the initial instance, when we first launched, we were supporting OBD devices, so working on any vehicle in the US since 1996, 1998 in Canada, 2001 in Europe, and at various other times in other territories globally. We focus primarily on a mobility-based product, so Android and iOS. That initially was targeted at passenger vehicles, and now we're supersizing that towards more commercial vehicles and trucking. That obviously is a product that convinces a consumer or any driver to plug this into their vehicle and hand us the keys to that data. And I'll talk about what some of the features are in our core consumer product and then in our trucking product. But that data then flows into our platform where we see it delivers value, depending on how it's harnessed, for everything from insurance, financial services, leasing and financing, to aftermarket, OEM, fleet, logistics, even billboard analytics, and then hopefully down the road, academia and also government agencies. So that's a high-level overview of what our solution is today. We are hardware agnostic. We work with multiple devices, everything from generics, which you can get for $5 on Amazon, right through to some of our more preferred hardware partners who have BLE devices, 3G-enabled devices that make us $200. We work with all of those. But it's always been a central part of our message that we wanted to make this accessible and affordable for people. We are OEM agnostic as well. We work on any car on the road since 1996, and we're multi-platform in terms of mobility. I'm going to skip over this because we're short on time, but this is if you guys go to our website, you can access it by going to dash.nyc. You'll see how the product works. But primarily, some of the feature sets are built around that value proposition of safer, greener, and more affordable. So from the top, we track all your trips, where you start, where you finish. We give you feedback while you're driving. You get a score out of 100 that goes up and down at the end of each trip. And that is based around things like...
Dash is a hardware and software product that will turn...
Can we kill that? Thank you. Some of the feature sets are built around tracking your trips, which you can then download for tax reporting and expense accounting. If you are minded to do so, you can share those trips on social media. As I mentioned, there is a score, Dash score out of 100. On the one hand, that does have a gamified element to it, but also it adds a sort of a proxy variable which can be used down the line for actuarial risk analysis for insurance companies. And we are actually working with insurers in Europe right now. We have a major launch coming out in August for a usage-based insurance product, which is built off the core Dash platform. We're also lucky to be part of the Drive Smart program here with DOT and Allstate and Metropia and Danlaw as well, where we are delivering savings for New York drivers if they can demonstrate safe driving behavior on their insurance. But the thing that excites us about that is the broader mission that the DOT has to have that data flow through into everything from traffic management, congestion reduction, improvement in terms of fuel efficiency, reduction of emissions, improving safety on the roads of New York. That's all the mission-driven stuff that gets us excited as well. We'll show you the last place you parked your car. If your engine light goes off, we'll explain to you what's wrong, how critical it is, how much it costs to fix in parts and labor, and where you can get it fixed nearby. We'll also show you where the cheapest gas is nearby. We'll show you driving trends over time, your maintenance calendar, if there's a recall, how much you can resell your car for. So it's a fairly robust set of features, and it will, will target someone who wants to use this once or twice a year when their check engine light goes off, or people who want to dock their phone while they're driving and have Dash running. We have a post-transit experience, which is a lot of the information I just mentioned, but also an in-transit experience, which has a much reduced set of data that we showcase. We don't want to distract you, obviously, so we have big, bright colors and a voice that speaks to you while you're driving and tells you if you're hard braking or speeding or over-accelerating. We also have tools for parents, for example, a curfew alert, a geo-fenced alert, or a behavioral alert. So if your kids are driving after curfew or in a neighborhood you don't want them to, or if they get into an accident, you can get remote notifications. So all of that software is for free for the consumer today, and several of those features work even without the OBD. So we launched that in January of 2014 on Android, August on iPhone. We went international fairly quickly, and we've been pushing out updates ever since. We have about 300,000 drivers now in 100 countries, 60% in the US, 40% international. Outside of the US, it's Canada, Australia, UK, Germany are our major territories. We were always worried when we launched this on two things: people wouldn't want to use it, they wouldn't see value in it, or that it might just be technophiles who used it. San Francisco, New York. The great news is that LA is our biggest market, and I think that's no surprise to anyone here who covers transportation and driving. But we see, as we look where our Dash drivers are, they are driving in places that people drive, so that's very gratifying. It's a mainstream targeting, not a niche. We've been very fortunate to get a lot of coverage in what we're doing. All of this press here has been earned, but we've also been recognized with awards from the White House, Department of Energy, Ford, Edmunds, and various other bodies. Now, as we look out to how we extend that platform beyond mobile to online, onto web dashboards, but also into other Internet of Things and connected lifestyle products and services. So we have something called an IFT channel. IFT is a service called If This Then That allows you to connect various digital experiences online without being a computer scientist or a developer. So in this instance, for example, we've created a channel where if you drive away from your home, then your Nest thermostat can reduce your temperature in the home. Same thing, if you're driving towards your home, can raise the temperature. If you are gathering your data with Dash, then you can also have that exported to a spreadsheet and sent to you at the end of every month for your business accounting, etc. So, we're also extending it to things like watches. The thing that gets us excited is how do we get that embedded into vehicles? As I'm sure you're aware, the OEMs are a fairly tough nut to crack. So one of the ways we're doing that is a secondary sort of over-the-top approach. We've started with mobile, but now we're looking at things like CarPlay, and we recently partnered with Google on Android Auto as well. So in terms of our roadmap, what are we looking at? We've been in market for 2 years now with our consumer product. Right now, you guys may be aware of some of the competitors in the market, Automatic, Mogio, Zuby. We have more users than all those companies combined, so that's been very gratifying to us on the consumer side. It's created a halo effect for the brand, but we're excited about how we take that now to enterprise. After we opened up our developer platform called Chassis, any third party can go and get a developer key from that and start building on top of our platform. Now we've started to build out a suite of insurance products and fleet products as well, and we will be productizing our data going forward with something called Dash IQ. I've covered here our participation with Drive Smart. I'm sure you're aware of that. In terms of the data, I'm going to close out here. We gather data from the vehicle via the OBD. That's one set of data, and it's very rich. But we also use the phone sensors, whether GPS, barometers, compass, accelerometers. Then when you authenticate or register as a user, we have demographic information on yourselves, so we know who's driving. And then finally, we take in third-party APIs for what we call ambient information to do with driving, weather, traffic, road conditions. Over all of those 4 buckets, we are getting 300-400 data points in real time, very, very rich in terms of depth and breadth. We are able to correlate that data cross OEM, cross device, cross user, across 100 countries, and that really is the promise of what we're doing. So while we're targeted today on the consumer and, as I mentioned, insurance and fleet, there are a lot of other areas that this can be commercialized as we build what we call the automotive graph. So this is the last slide. We see ourselves as part of a broader big data, Internet of Things, connected lifestyle trend. You have the Nest for the home, you have physical activity trackers like Fitbit and Nike Fuel, and now you have Dash for your vehicle. So with that, I'll wrap up, and thank you guys. Feel free to reach out to me if there's any follow-up.
We're still on time, so we'll take a question. We're going to go to the back. We're not giving them fair justice. No? Okay.
So would it be possible then, there's some demographic information from National Highway Statistics on accidents that is historically not collected at all? And that is the purpose of the driver's trip when they were involved in an accident. Now that's just a special case, but could you use your platform to validate, say, what percentage of personal driving is for, say, shopping?
Yep, absolutely. We can. So
I need to talk to you.
we create metadata around point of origin and point of termination. So not only, if you're pulling up into a Dunkin' Donuts or Walmart parking spot, we then have several other ways that we categorize that. We actually did a presentation at the Ad Age Data Conference last year where we presented some work we had done with CBS Outdoor, which is a billboard company. They were interested in getting rich analytics on who sees their billboards. We presented a lot of similar information. I think the use case that you're talking about is much more aligned to our vision.
Okay, one more over here, then we're going to move on. 4 o'clock sessions will appreciate this.
Do you collect any specific data on electric vehicles, such as amount of kWh consumed?
Right, so
any charging information, like similar to what Fleet Karma does?
So we're given the OBD spec, which is open protocol, there are proprietary codes that the OEMs keep for themselves. We are limited by what comes out there and what we can purchase. We're primarily targeting everyday vehicles, but we do work with hybrids. In fact, Prius drivers are our biggest cohort of users, and we do work on electrical vehicles that have that OBD port in it. The Chevy Volt, for example, has that, even though they're not obligated to do so. In the Nordic region, which is where our insurance pilot is, Teslas are very big there, and we can access the port there. So I can't answer you directly about the charging level, whether we get that. I'm not sure that we do from Teslas or Volts, but I can follow up with you on that.
Yeah, I'd like to speak to you after about that. Thank you.
Okay, great. Thank you.
Okay, hey, I'd like to compliment you on your name of your company. I'm always amazed by these companies that pick these weird names. I mean, Dash, that really hits it. So next, Dr. Kornhauser is going to speak to us on autonomous taxis for eco-mobility.
What else would I talk about? If we can, is that the latest one? Yes. Easter. Here we go. Autonomous taxis. I think the 2 important things, not to give the takeaway as to where I'm going with all this, will be this and will be that with these things. So, automated driving. Seems like there's a lot of news about it. There's a lot of technology. Today, it's really all about safety, and it's probably anti-eco, but it's really about safety. Ultimately, though, it really is about enhanced mobility, and that enhanced mobility is on-demand mobility for all, so all those that don't currently have it, substantially more inexpensive, substantially safer, because we did the first step. If we don't do the first step, we don't get here. So we have to do the first step, otherwise we don't get there. Substantially more energy efficient, substantially lower in greenhouse gases and other pollutants, and basically eliminate congestion. So that's where we're going. How do the AVs address the challenge? Well, I have a bunch of videos that you've seen. We won't bother talking about it, but you know, there's been some levels, because we don't really have time to go through the videos, been some levels that NHTSA has talked about, level 1, 2, 3, and 4, progressively more automation in terms of the function. The levels 1 and 2, which are basically your automated collision avoidance, which is getting to be available in all cars. Nobody seems to be buying it, which is really unfortunate. The automakers have said that by 2020-something, it will be available in all cars. And really what this does provide is it really provides safety. I've had it in my car for almost 2 years. I haven't had an accident, although, you know, and of course I'm a good driver. And maybe it worked, maybe it didn't, I don't know, but really the whole purpose of the automated collision avoidance systems and the lane keeping systems is to keep you from being stupid. You know, you're a good driver as long as you're paying attention. But unfortunately, and as we're finding out, the really bad news that came out lately was in 2015, the deaths on highways in the United States went up 8%, and VMT went up only 3.5%. How does that happen? Well, we know how it happens is because everybody's doing this now. If you're doing this, then you need something to bail you out, and that's really what these systems do. It's all about safety, some comfort and convenience, and in the end, it's an insurance play. And I'll make an argument as to how insurance is actually, when they finally wake up, is going to make that happen. Level 3 is really where Elon Musk wants us to be in our Teslas, basically for most of the trip, not dealing with the darn thing. Really, I call them the ultimate texting machine, because I'll just be able to text. And I'll be able to watch Dash, and I'll be able to do everything else, because I won't have to drive from milepost whatever to milepost whatever on the New Jersey Turnpike or on the Bell Parkway, maybe, and it'll just do it for me, and that is an enormous comfort play. Now, for all of us here, we should be really weary about this one, because guess what? We're going to increase person miles traveled out of this, because as Stan suggested, we make some of our decisions based on the disutility of the travel, and the only reason we travel is because the place-time utility gain that we get out, instead of being here at this particular point in time, to get there at that particular point in time, for which we have a utility, hopefully, increase associated with that. And the only reason we don't do those things is because maybe the disutility of doing all that stuff negates all the utility, so we stay home and watch TV or play on the internet. But all of a sudden, if we change that disutility and basically drive that disutility to zero, who knows what can happen? And so certainly the person miles desired are going to go up, and if there's a vehicle to make it happen, then that's where we are. So in a sense, to be able to get to the greenhouse gas charts that we saw, 80% reduction, holy mackerel, in between in this process, we're going to, I don't know, maybe. These things are inevitable. I claim they're inevitable because one only needs to have the automated vehicle technology work on a single vehicle. We don't even need government to do this. Garages are doing it. We don't need help, and all we need to do is put that to work in one vehicle and then just replicate, and the replication costs are epsilon. And so therefore, all the people are working in their garages to make this work. What's the definition of work? Well, I'll claim that the definition of the work is that the cost of the technology is less than the net present value of the expected liability savings that that technology will deliver. Because if in fact it does deliver the safety, as we know, or as NHTSA tells us, it's $871 billion a year in the United States, apparently, in economic cost because of the lack of safety in this. Divided up per individual, it's $2,800 and so on. There's a lot of money on the table here. And everybody sort of agrees that maybe we won't hit the 78% reduction in safety that Google suggests. 50 is really easily attainable. And even the warning systems give us 20. So in a sense, since this technology does not really require any infrastructure because it's all in the vehicle, the intelligence is put in the vehicle. AlphaGo goes in the vehicle, doesn't play Go, goes in the vehicle to make all this stuff happen. Then all of a sudden, all this stuff also involves Moore's Law, so that we know wherever we are now, we know we're going to improve. We're going to double the improvement in a year and a half and chop the costs in half in a year and a half and so on. So it's definitely, if it's not heading to epsilon, it's heading to delta. So it's getting smaller. And the inequality will be achieved. And in a sense, some insurance company's going to see, instead of paying for the undertaker and the MRIs and the new vendors and the lawyers, geez, why not keep the money in their pocket and maybe spin off a couple dollars for the technology, and all of a sudden, everybody's happy. So what about that? The next step, which is the driverless, the level 4. When you can finally take the last person out of the vehicle and have it move around empty, okay? Why do you have to have it move around empty to be really good here? Is because empty vehicle repositioning ends up being the name of the game to be able to use this thing in a mass transit environment. You know, what good's a taxi driver? Not to drive me, it's to get the taxi to me after the last person who was in it got out of it. That's the only really good of a taxi driver. In a sense, what good's a bus driver? I could drive the bus, get it from the car barn out to where I am, you know, I'll drive it. Maybe, I don't know, probably not very well. So in a sense, you know, to be able to get to that, and we've tested that in all sorts of controlled environments. We've yet to go 1 foot in an uncontrolled environment yet, but in some sense. But when you can take that person out of the van, then all of a sudden you have an autonomous taxi. And then that could be a really powerful thing because it eliminates the cost of transit, the labor cost in transit. We eliminate the labor cost in our own mobility by buying our own car because we enslave ourselves to be a driver. And it is an enslavement to do that task. When New Jersey Transit tries to do it, they have to pay people. Just think if they could do that without having to pay people. Then in fact, they might be able to put a vehicle out there that is basically small enough and frequent enough and on demand enough that somebody might want to use it. So instead of mass transit usage in the nation is what, 2% of the trips? Might be less than bicycles. You know, all of a sudden, why is that? It's because, my goodness, if you have to provide labor to be able to provide that mobility that people seem to want, you can't afford it. I mean, you can't afford it even where you're providing it, but you certainly can't afford it where you're not providing it. But if you have the opportunity to take that labor out, then there may be, you know, all of a sudden some really massive opportunities. So for the last at least 3 years, I've been trying to figure out really, is this any good or whatever? And so I tried to use a bunch of data that was available or not available, wasn't able to do it, decided to say, heck with it, what we're going to do is I'm just going to go out and build it myself and synthesize it. So decide to synthesize every individual in New Jersey, all 9 million people, from publicly available data, and so on, and basically assign to each of those persons with the publicly available data what they might do during the day. Like maybe they felt good enough to go to work. They went to work, and maybe they went to lunch, then maybe they came home, and their kid might have skipped school today, or maybe they went to private school or something, whatever, and went to soccer, and they do and all that sort of stuff, and now that built to 32 million trips. Explicit 32 million trips that take place in a typical day in New Jersey, from wherever to wherever, to the Starbucks and to the so on, so that Stan can get his Starbucks and whatever, have that in there. And just build it with specific times. Why? Because I don't think anybody's collected the data yet. Well, some people have collected a little bit of data. They haven't collected the 32 million that take place approximately every day, or the billion that take place every day in the whole country. So we decided to build it. And because we put in that specificity and the location and timing and so on, we could then test to see what, how would you really move these people if they all didn't have a physical car attached at their hip, which is what they have now, Outside their kitchen door, there's a car. Outside their office door, they park it. Outside the Starbucks, they park it, and it waits for you like a little puppy dog and so on. It ends up having pretty good statistics and so on and so forth. And when we sort of then decided we'd pixelate New Jersey, and we hypothesized that maybe what we're going to do in New Jersey is create autonomous taxi stands within a quarter-mile max walk to everybody. In a sense, I find we have a way to basically be able to see whether or not, if we then took all of this stuff as to where all the people are and where all the trips are, and there are places you can go and look at it and so on, and see whether or not there's an opportunity to share, if in fact there was an easily accessible place to go to where then people might just show up and by walking or something, and whether or not they could do that. And then use the elevator analogy, because I think that the evolving transportation system that evolves out of this thing really does look like an elevator that we have in World Trade Center 4 or something, or even some of the other buildings here in Manhattan. There's a place that you go to, and you might be on the 5th floor of the darn thing. You press a button up or down. 2 elevators come, doors open, one's going up, one's going down. You go to the up one if you're going up, or the down one if you're going down. And the door stays open for a little while, and in case anybody else happens to show up at the same time, you, of course, hurry up and try to close the door, but, they can put their foot in there. And I'm sure you've all shared a ride in an elevator. And you've also had some on-demand private rides, too. My goodness. It served you on the on-demand temporal spatial aggregation scale that you kind of, well, why not do this with horizontal mobility as opposed to vertical mobility? And that's basically the trial out of all this thing. A note about ride sharing, I'll use the term average vehicle occupancy on this because, again, it's not car sharing that's important. Trust me, that doesn't do anybody any good. It's ride sharing that's important. It's the number of person miles of mobility that you desire divided by the number of vehicle miles of greenhouse gas polluting junk that you put those people in. The numerator is what improves our quality of life, and the denominator is what screws up the planet. Okay? And if you look out there and you go to a typical DOT source, they'll tell you that average vehicle occupancy is 1.5. I don't believe it. I think average vehicle occupancy, except for Manhattan's different, okay? I don't say anything about Manhattan. But every place but Manhattan, it's at best 1. And I know in Princeton, in the morning, it's less than 1. Why? Because there are so many parents that chauffeur their kids to the school and then go back home. So the person miles of quality of life mobility that's delivered, the numerator, is 1. But the vehicle miles traveled is 2. It's 0.5. You see two people in a car on New Jersey Transit, on New Jersey Turnpike. One of those persons and maybe chauffeuring. And you see a lot of people with only one person in there, they're being a computer to bring the car back. So that in fact, it really does look like 1 is a pretty good number, and the question is, and so really what we went out and did is testing a casual ride sharing, and I got to go through a bunch of stuff. We actually do this stuff, go through, put people together, see if they put together and so on. Maybe we'll have somebody maybe who's going there. If you're going up, somebody might get in. You're going to the 42nd floor. Somebody might get in, go to the 12th floor. You might have to stop. So we check the opportunity and the implications on the utility with respect to all of that stuff. And basically the bottom line on that, if I can move, be on. We also kept the New Jersey rail system in there in our simulation because guess what? If you're going to New York, we're not going to send these autonomous taxis to New York. We're going to put you on a train. And therefore, we're going to take you the last mile, so-called, and people are going to want to do it because you don't need parking because it's going to drop you off, and it's going to be there when you get back, and so you'll just take it and whatever, and I'll be able to take you there. And in a sense, with doing all that stuff, you take the train to Princeton Junction, there's a thing waiting there, it takes you home. And out of our whole stuff, what does that give you with respect to New Jersey Transit? It increases the ridership in New Jersey Transit by a factor of 5. That means instead of trains running every half hour, they run every 5 minutes. The mobility and throughout the thing is really enormous. What happens with respect to average vehicle occupancy? It's good. It's maybe not as good as I had hoped. Salem County, man, it's tough to find anybody else to ride with you. Okay? Hudson County, you have a choice. And in a sense, if you look at the chart that's down here, really you can achieve with a really very good level of service an average vehicle occupancy of 2. But the fact is that we, in fact, could reach 2 for the 32, well, out of the 32 million trips, 2 million of them are walking, 1 million of them are bicycles or something like that, so it's really 28 or something million trips that do that. So what this thing does for us, and this is my last slide, it basically takes this and it removes that guy with Moore's Law. And out of this thing, just doing that basically reduces the cost of a trip by a divisor of 8, maybe almost an order of magnitude. If we decide in this process, the good thing about it is that we share the road, which means we don't even have to ask New York DOT for anything or anything more in some sense like that. So there's really no capital cost that's involved in this thing. Maybe some, but not a whole heck of a lot. When you start sharing the ride, which Stan started talking about, that's really good. That's the piece where you go from an average vehicle occupancy of 1 to an average vehicle occupancy of 2. Then what happens to fuel consumption? Fuel consumption is a divisor of average vehicle occupancy. So out of that, you chop it in half. What happens with respect to pollution? Hey, you chop it in half. It's not 80%. But it's a solid half. And what happens now if you do the combination of all of this with respect to doing the average vehicle occupancy on the price, it's not only the divisor is 8, it's 8 times the multiple on average vehicle occupancy, so that you're now 1/16 of the price. So that in fact now the mobility is affordable by everybody, and in fact you aren't going to buy one of these things. You're just going to be chauffeured like you're in Downton Abbey. You got the chauffeur coming out, taking you to whatever, or taking you to the train station. And out of that, because of all that, and because of the shared ridership is 2 over the 24 hours of the day. In the peak hour, peak direction in New Jersey, the average vehicle occupancy goes up to 3.54. You take out of every 4 cars, you take 3 of them out of Route 1, there's no congestion. So in a sense, out of this thing, you get the congestion savings. Thank you.
Okay, I'm afraid we're out of time, but we're coming up to a short break, so please track down our speakers if you have more questions. We'll be right outside in the foyer here, and please thank them for their presentations this morning.